This talk is about how to break XML encryption automatically, and it is a joint work with my colleagues Dennis Kupsa, Christian Meinka, Jörg Schwenk, and myself. And it was actually submitted or presented at the WOOD conference, which is Workshop on Offensive Technologies, in 2015. So this year in summer. And what we did, we extended our attacks on XML encryption and make them work automatically so that everybody can verify whether their implementation is correct. So, short info about me. So, I'm a security researcher at the Ruhr University of Bochum, at the chair for network and data security, which belongs to Professor Schwenk, and we are doing some stuff on web services, single sign-on systems, cryptocurrencies, SSL/TLS, and applied crypto attacks. We are doing attacks and provable security, and our chair is part of the Horst Gross Institute for IT Security, which does further stuff like malware analysis and this. Okay, and we also provide some penetration tests and security analysis in these areas. Okay, so in this talk I will present attacks on XML encryption. I will give you an example how XML encryption works in web services. And so first we are going to talk what is a web service and XML security. Then I will present you some XML signature wrapping attacks which are necessary to understand the complications of applying countermeasures. Then I will present you the general idea behind XML encryption attacks, and I will give you an example of our attacks on symmetric key encryption scheme. And then I will discuss the countermeasures, and I will present you the tool, how it works, and what are the ideas behind the tool. Okay, so let's start with web services, with some basics. So what is a web service? In this talk, I'm going to talk about SOAP-based web services. So we can imagine we have a client and a server, and the client wants to execute some remote function. And in order to execute this remote function on the web server, we use web services. So for example, the web server provides a function getPrime, and the client sends through the wire getPrime function and wraps it into elements, envelope, and body. Yeah? The server generates some huge prime, like this one, and afterwards it wraps it into the message and responds to the client. Okay, so this was a very simple example, but we have more complicated ones. So for example, the client can talk over a broker to the bank, insurance company, make some flight reservation, and so on and so on. This is also possible using web services, using some redirection and so on. And we can ask, so how about security in these scenarios? So how could we apply security? Many of people who I'm talking to say, okay, we can apply SSL/TLS, but what is the problem? In SSL/TLS, the messages are secured only during the transport. So if the client sends a message, he sends it over the secure channel to the broker can see the message, maybe can see some confidential data, some credit card data, and send it to the bank or insurance company. So the problem is that messages are secured only during the transport. So what we need to have is some kind of message level security. So apply some lock on the message, send it through the wire, and the broker cannot decrypt it, cannot modify it, because the message is secured directly, and only the bank and insurance company can then decrypt the message. So this is achieved using XML security, and XML security is actually a standard which describes how to apply cryptographic algorithms to XML messages. So it consists basically of two standards. It's XML signature, which allows you to protect authenticity and integrity of the data, and XML encryption, which protects confidentiality. What you need to know that these standards are very flexible. So you can, for example, encrypt and sign the whole document. You can encrypt and sign only parts of the document, like text elements, or you can encrypt and sign a few elements at once. It is used, for example, by ID cards from various European cities, countries. It is used in appliances like IBM Data Power, or there are banking standards which use XML security. Okay, so now to give you some ideas behind the problems in XML security, I present you the first attack. It's called XML signature wrapping. So now we can see a message invocation with body containing monitor instances. Yeah, this is a simple message invocation, message function invocation. And what we do if we create an XML signature, we want to secure this message. So we create a timestamp to protect the freshness of the message. And then we take a signature and a reference element, and we reference the body element and the timestamp elements using an ID-based referencing. Afterwards, we compute digit value over these elements. And at the end, we compute signature value over the signed info. Okay, this is XML signature. What is the problem? The problem is XML signature wrapping or XML signature rewriting attack. So what the attacker can do, he can, for example, take the body, the original body, place it somewhere into a wrapper element. So, for example, into the header, can place the wrapper element, move the original body to this wrapper element, and since the ID of the document is the same, now the reference references this moved body element. And now the attacker can define new data. So he can actually overcome the signature method, signature protection, and create new function invocation. This attack was actually described in 2005 by two independent researchers, by McIntosh and Oster, and by Bhagawan et al. So why does the attack work? So let's take a look at the message processing. So typically, the servers consist of two logics. So there's a verification logic for XML signature validation, and there's an application or business logic for the message invocation. So, and what the verification logic does, it goes to the envelope, header, security, signature, reference, takes a look at the URI body, finds the element, and verifies it. So everything's good. So the message is still authenticated, and the application logic just takes a look at envelope, body, and invokes what's in the body. So that's a problem from different views at the same message. Okay, so you can mean this attack is only theoretical, but in 2011 we showed first attacks on it applied to Amazon and Eucalyptus cloud interfaces. So Amazon and Eucalyptus used for the control of their virtual machines SOAP messages and signed SOAP messages. So the client could use SOAP messages to send it to the cloud control, and the cloud control verified the signature and could somehow initialize the virtual machines. So we could, for example, take the SOAP message, modify it using XML signature wrapping, and send it to the cloud control and get the instances of the victim. Okay. More recently, last year, my colleagues presented a huge study on SAML-based interfaces in software as a service scenarios and clouds. And SAML is actually a standard for single sign-on applications. And they analyzed other attacks, maybe you know external entity attacks. They found out that 10 out of 22 applications are vulnerable to XXE, and they, of course, analyzed also XML signature wrapping and found out that 1/2 of them are vulnerable to XML signature wrapping. So they could also authenticate it as an arbitrary users at some cloud software as a service platforms. Okay, so we have now some basics about XML signature wrapping and what are the problems. Now we are going to describe what is the basic ideas behind attacks on XML encryption. Okay, so typically in XML, and when we use XML encryption, we use a hybrid encryption scheme. So what we do is, if we want to encrypt the data, so we construct an encrypted key and an encrypted data element. And into the encrypted key, we we use asymmetric encryption to encrypt a session key, and this session key is then used to encrypt the data into encrypted data. Yeah? And for this purpose, we use algorithms like asymmetric encryption scheme is RSA, for example, and for symmetric encryption scheme, we use ASCBC, for example. Yeah? And then we create some binding between encrypted key and encrypted data using data reference. Okay. The problem is that in 2012 we presented some attacks on asymmetric encryption scheme. We used so-called Blackenbacker attacks, maybe you know, from 1998, and we showed how to extract the symmetric keys from the web service. And in 2011 we showed also the attacks on encrypted data, so we could decrypt data from the plain text data from the web service. I will show you a demo later. Okay. What you need to know for now is that these attacks are adaptive chosen ciphertext attacks. Yeah. So what they do is there's an adaptive chosen ciphertext scenario. So imagine we have a client and a web service, and the client wants to send data to the web service, and encrypted data. So it sends to the web service some ciphertext, and the attacker eavesdrops the ciphertext or somehow gets the ciphertext. What the attacker does, he uses the web service as an oracle, sends modifies somehow the ciphertext, sends it to the web server processes it, and responds with valid or invalid according to the message validity. The attacker repeats this several times, and at the end, he can decrypt the message. Yeah? This is just a general scenario of adaptive chosen ciphertext attacks and how they work. And as already mentioned, we presented attacks on symmetric encryption scheme in 2011, where we could, with 14 server queries, we could extract a plain text byte, and with about 400,000 server queries, we could extract the symmetric keys from the server. Okay, and in the next slides, I would like to present you the attacks on symmetric encryption scheme. So the basic ideas behind it. It will be going a bit deeper into the details, but don't worry. If you know how the adaptive chosen ciphertext attacks work, you are fine. So it's not that complicated, bear with me. Okay, so attacks on symmetric encryption scheme and how do they work? Good. So we already showed the attack scenario. So in the attack scenario, the attacker sends modified ciphertext to the server, and the server responds with whether the plaintext is valid or not. And in the next slides, I will show you what is a valid plaintext, why we can use a web service as a plaintext validity oracle, and how to use it to decrypt the ciphertext. Okay, plaintext validity. So XML is a text-based data format. So every XML message which arrives has to be parsed. And the characters which are contained in the XML are usually encoded in ASCII format. So what is ASCII? ASCII is a format which allows you to define 128 characters and symbols. And as you can see here, you don't need to read everything, but what we see here, there's on the left, there's some null character or null symbol. There's some bell symbol on the left, and there's some escape symbol. So in the left column, we have some specific characters, and we call them these are type A characters. They are not parsable. Then we have some specific characters like ampersand or left bracket, which are some specific characters for XML. Yeah? These are also type A characters, and then we have here on the in the left column we have some horizontal tab, line feed, carriage return, and so on and so on. And other characters like from the alphabet, these are type B characters. So we have, and we say that a valid plaintext contains only type B characters. So it contains only characters from the alphabet, and the the web service can parse only these characters. Okay. So why we can use a web service for plain text validation? So what we do is if we send a modified ciphertext to the web service attempts to process it. It processes in 3 steps. First, the message is decrypted. Then the message should be parsed, as already mentioned. And then there is some evaluation of business logic operation. The problem is that there is this XML parsing step. And if this parsing step is invalid, then we get some failure. So if we send to the web service some invalid plain text, then we get some parsing error, and from this parsing error maybe we get some fault message. So this could be problematic because this could be used as some side channel. Okay, so based on the modified ciphertext, we could somehow make the web service proceed with a parsing error and to repeat with a fault message. Okay, so what can we do with it now? So let's take a look at this ASCII table again. So we have here this type A and type B characters, and we said that we have 128 characters. So if we consider an ASCII character, the first bit is always 0. The bits 1 and 2 are defining the column where we are, and bits 3 to 7 define the concrete row. Okay, so this is ASCII exhibits a nice pattern of type A, B characters and some nice characters. Now suppose we can flip arbitrary bits in the plain text without knowing the key, and we can use the oracle. So what we can do? We can flip the plain text bits. So let me give you an example. So imagine we have ESOP a ciphertext which contains an encrypted plain text black hat, and we want to recover the first character or the bits 1 and 2 of this character B. So what the attacker does not know where we are, and he wants to recover this. So imagine we are in this third row on the character B, and what happens now if we flip bit 2? Without knowing this, what happens now? Okay, if we flip bit 2, we jump to the right. Yeah? We are still valid character. If we flip now bit 1, we jump to the left. And if we flip bit 2 again, we jump to the left column, and there is an invalid character. And if we send this ciphertext to the server, once the server answers with a fault message, and we knew that originally we were in this column. Yeah, because if we flip bit 1, we jump to the left, then we get a fault message, and we knew that we are here. Okay, this is just a basic idea behind these attacks. Why is bit flipping possible? Because of CBC mode of operation. So CBC mode of operation allows you to flip bits. So example, you have an initialization vector and ciphertext block, and if you want to decrypt it, the ciphertext block goes to the AS operation function, and the initialization vector XORed to this value. So if XOR a bit in the initialization vector, XOR also a bit in the plain text. So this is the basic idea behind the attacks. And it was also applied in pending oracle attacks, if you know them. Okay, or attacks like Voodoo. Good. So this way we could decrypt like 14 queries, using a byte with 14 queries to the server. Okay, so this is quite performant. And now maybe you ask which countermeasures can be applied. Okay, so the basic idea behind applying countermeasures is to protect the integrity and authenticity of the messages. So the messages are not modified, because if the attacker can modify the ciphertext, maybe he can force the web service to produce some fault messages. And now let me give you an example of what could go wrong. So the first problem is XML signature wrapping, as I already mentioned. So imagine we have this message, And in this message, we have a signature which protects actually the SOAP body, which is encrypted. What the attacker can do, he can, for example, move the SOAP body to the security header. And this way, the signature protects now the body in the security header, and he can define all encrypted elements in the SOAP body and force the web server to process them. So this way, the signature is always valid, and the data is decrypted, and the attacker can modify it because it is not protected. Okay? So this is the first problem. The second problem, what we also can do is we can execute so-called XML encryption wrapping attack. So there we can leave everything as it is, but we define some new encrypted key and encrypted data element, and we force the server to process them. So what we do is, what the server does, he just executes signature validation, decryption and business logic operation on the original data, and the newly defined elements are used for decryption. And we can modify it, and we can produce some fault messages. Okay, so the question is how to analyze it automatically. So we saw there are some complicated problems, like we have some crypto attacks on a asymmetric, symmetric encryption scheme, we have some signature problems, and so on and so on. How can we analyze this automatically? And this is why we constructed WS Attacker and a new plugin for this. So WS Attacker is automatic penetration testing tool for web services, and it's open source. You can you can find it on GitHub. And it supports many attacks like subversion spoofing, WS addressing spoofing, and so on and so on. Also some denials of service attacks. And in our recent work, we published or we implemented a plugin for XML encryption. So what is the basic approach behind this plugin? So the plugin processes in 3 steps. So first, it analyzes the message security. So what protections the message has, then it removes some signature protection if there is a signature protection, and afterwards it executes the attack automatically. Okay, so once more, so we have 3 steps. So in the first phase we have a detection phase, then we have some avoid phase and attack phase. So the input encrypted XML file goes into the detection phase, and where we have to identify the security elements. So imagine we have this message, and it has some security elements, and we analyze, okay, there is an encrypted key element which is used with encrypted data. Then there are 2 signature elements. The first signature element protects the body element, and we have a second signature element which protects the timestamp. So this is the first phase in the analysis. This is done offline. This information into the knowledge pool, and go to the avoid phase. And we ask, okay, is there a signed timestamp or not? So we can then, oh, cool. So if this does not work, maybe we can try this XML encryption wrapping attack. Yeah? And if everything goes well, then we have to identify the oracle. So you remember, so we are executing adaptive chosen ciphertext attacks, and in these attacks we send a chosen ciphertext to the web server, and the server responds with OK or with a failure. And what we actually get from the web server are some stack traces, maybe some error messages. We need to map it to this true or false, or to valid or invalid messages. So we need to construct an oracle from a web service. Okay, so this implementation dependent, so some implementations use some stack traces if they are wrongly implemented, or maybe there are specific error messages. Okay, and at the end, if we identify the oracle, we can apply the attack and decrypt the XML message. So what we did in our paper, we analyzed 5 servers and applications: Apache Axis2, Apache CXF, IBM Data Power, X-Ray, Gateway, and Microsoft. and in their default configurations. Yeah. So in the asymmetric attack, we could attack Apache CXF and XFAY gateway, and in the symmetric attack, we could attack Apache Axis 2, CXF gateway, and data power. The Windows or Microsoft framework was not vulnerable because they use good countermeasures. But in general, if you play with the countermeasures and with some configurations, you can also achieve good validation on XFAY, data power, or Apache CXF. Okay. So I will show you a demo of the tool. Okay. So what I have here now, there's an Apache Axis 2 web service, which simply decrypts a message, and we initialize it with a so-called WSDL data. So it's SOAP description standard, and we can start now WS attacker. Okay, so we load the WSDL, which is provided by the server. We can choose here some bindings, and what I do now, I have here now some encrypted message. So we can see here, that's what I described. So we have this cipher value, this the asymmetric ciphertext. We have here some RSA encryption scheme, and we use AES in CBC mode. Okay, so my goal is to decrypt this message. So what I do, I initialize the framework WS attacker with this message, and by sending it to the web service, the server responds it, and now there's this detection phase. So the WS attacker initializes the plugins and wants to find out which attacks are applicable, which XML encryption signature standards are applied, and so on and so on. Okay, so now I can move to plugin configuration. So as already mentioned, WS Attacker is a few years old, and it contains several plugins. So if you want to play with it, you have several denial of service attacks. You can execute like XML and external entity attacks and SOAP array attacks and so on, cursive parsing attacks and so on. You have also some spoofing attacks. There are specific SOAP message attacks, and you have, of course, attacks on XML signature, so signature wrapping attacks, and attacks on XML encryption. So what I'm going to present you, of course, is XML encryption attacks. Okay, this is quite complicated now because I have. Okay. So what we see now? So the tool analyzed, okay, we have one encrypted key here, and for us we can execute a CBC attack or PKCS1 attack. I'm going to execute this attack on a symmetric encryption scheme, so this CBC attack. And you can, if there would be an XML signature, you can choose, okay, I want to use some signature wrapping or encryption wrapping attack. We are not having a signature. Here there are some coefficients which I have to set. Is for the recognition of the oracle, and now we can say, okay, we want to choose either the PKCS1 attack payload or the CBC attack payload, so the symmetric part. We want to attack the symmetric ciphertext, so we chose it, and at the end there's the step where we want to identify the oracle. So you remember when I send the messages to the oracle, to the server, I want to construct valid or invalid responses to identify the messages. So what the framework does, it sends several thousands of messages to the server, and tries. Then I manually can map it to valid or invalid based on the message validity. Okay. So I send it to the web service, and I basically get two messages back, and I can analyze them. So there's this request, and we get some. Okay, there's some valid encrypted response. So this would be probably a valid message. And then we have here the message number 1. Contains some you can see here, okay, it's only a stupid demo web service, so there is some stack trace. And we know that this is probably something invalid because we produced some stack trace error and so on. Okay, so we set this message to invalid. Okay. And then we set up our framework and the web service, and now we can go further with the attack. So we just run start, and the attack is running. We can take a look at the log messages, and what we can see now. Okay, so we are sending these messages to the web service, and every like 14 request bytes we can decrypt a plain text. Okay. So after several requests, we can get the whole ciphertext decrypted. There we can see it. So you can see it's like in these James Bond movies where the ciphertext are decrypted and so on. So if there is anybody working for the movie industry, please propose this tool for. I would be very thankful. Yeah. So our dream is to have this tool that's applied in the movie. Okay, so we can see at the end we have a plain text which we decrypted. So we can see there are some elements with some namespaces, and there is maybe some secret message. This is what we decrypted. Okay. So these are the basics of the attacks and how we can use them. No. Okay, as you can see, I prepared also some backup slides if something would get wrong, but I was lucky. Okay. So if you want to play with it, you can of course download the source code of the tool and compile it, or use a release that we provide. There is nothing like damn vulnerable web application or something like this for web services, but you can use the newest version of Apache Access 2 and Rampart, and their basic configuration. They are vulnerable to nearly all of attacks of WS attacker. And in our blog post you can see how can you configure Apache Access 2 and how can you play with web services on your own if you want to start with this. Okay. So how can we apply secure countermeasures? So I already mentioned that we need to protect the authenticity of the ciphertext, and what we need to do. So if we know in general ASCBC and RSA-PKCS 1.5 are insecure, but they are still deployed, and we need to cope with them. So if we use them, we need to ensure that the messages are always authenticated before they are decrypted. XML encryption was also updated, so you can use ASGCM, this authenticating mode of operation, if you have the possibility to use it. So use secure algorithms like RSA OAP and ASGCM. If there is no possibility to use them, you can use directly. So before the ciphertext is going decrypted, use XML signature to validate it. There's an example of IBM data power, so you can use specific configuration that only selected elements are decrypted, and you can define okay, the signature protects them. You can take more information from our paper where we describe how the countermeasures could be applied. Again, on Apache CXF or in data power. Okay, so in conclusion, I presented some XML encryption and XML signature wrapping attacks. XML security is pretty complex, so we have to cope with specific crypto algorithms, signature algorithms, and vulnerable encryption schemes. If you use in your company XML encryption and XML signature, you can use WS Attacker for its evaluation. And in general, we applied, so WS Attacker is applied on web services, SOAP-based web services, but you can use the libraries from WS Attacker to attack like other XML-based frameworks as well, XML, or you can apply the ideas behind the attack to JSON or Web Crypto API. So if you want to do research in this direction, you can take a look at JSON Web Encryption or Web Crypto API, how to use their encryption standards. And if you use your XML encryption and prefer authenticated encryption schemes like ASGC and RSA OAP, and further attacks are described on our website wsattacks.org. So thank you for your attention. Okay. Questions? Yeah.
Do you have any data on what the average amount of requests is sent during it?
The question was how many requests are sent during the attack. So in this XML encryption that I presented the attack on a symmetric encryption scheme, you need 14 requests per byte. So you saw that this was quite fast. If you attack the asymmetric encryption scheme, this depends on the validation of the web server. So you need maybe 400,000 server queries or 1 million server queries, but then you decrypt the session key, so you can directly decrypt the symmetric data. Yeah. Okay. Yeah. So the question was why was the Microsoft framework not vulnerable? So the Microsoft framework is pretty good. It is restrictive, so it allows you to apply only specific configuration of the web service. So you have only, as a developer, you have only 3 configuration possibilities. So apply signature, also apply no security, apply signature, or apply XML encryption. And if XML encryption is applied, then always signature is validated before. There were no possibilities for executing a signature wrapping attacks because they did a strict validation. But this was also caused maybe by the frameworks like IBM Data Power. You want to have like a general protection mechanisms. You want to configure it so the basic examples that they provide are vulnerable. But XML, Microsoft is just a framework, and yeah. Okay. Yeah. There was a question about German banking systems and whether they are vulnerable to XML encryption. I'm not aware. So there's a specific standard called EBIX or European Bank, I don't know, but which defines that XML encryption should be used in banking systems. So I assume the large banks implemented it, but I have no idea. So we have not cooperated with banks together and to evaluate it. So I don't know. But I know that some banks implement XML encryption. Yeah. Yeah, okay, so we executed the attacks in 2011, and at this point of time there was XML encryption 1.0, and based on the attacks we implemented, so this was an attack on the XML encryption scheme, and they added these considerations into XML encryption 1.1, where they say, okay, you have to first verify the data, and then you can decrypt it, and you have to pay attention, and they in addition added ASGCM mode of operation, which is authenticated. So yes, it was failure in the standard, I would say. And this XML signature wrapping attacks that I presented before, they were like, they were in the standard. You have to pay attention that you don't have it. So this was like implementation issues. Yeah. Okay. Any questions? So yeah. So this is what should be actually done. Yeah, this good point. So if you have created your ciphertext, you always have to protect it with the XML signature. So the server always first verifies the signature, and then decrypts only if the signature was valid. Yes. But there were the problems with signature wrapping and so on. No, this does not help you. No. Yeah. I'm sorry. So the question was, have you evaluated any XML implementations? I took a look at some of them, but I didn't we didn't write a paper about this. So this XML is not that heavily used, because most of the XML implementations use only signature to protect the authenticity and to protect the login mechanisms. But XML encryption not that well used in XML, so we had to know that huge motivation to evaluate it. Yeah. But it's possible to apply the attacks if you use it. Yeah. Okay. So if there are no further questions, yeah. Very good question. So the question was, I showed some Oracle based on invalid messages. What happens if maybe the messages are always the same? So what can I do with it? So maybe I can use some other side channels, like timing-based side channel, and we did not analyze it for the symmetric case, but in our 2012 paper, it's attacks on the asymmetric part, we analyzed also timing-based side channels. Yeah? So if the ciphertext, the asymmetric ciphertext is decrypted, then the server proceeds further with the decryption of the symmetric ciphertext. Lasts longer, of course, and if the asymmetric ciphertext is invalid, then it directly responds with a failure. So you have a direct, so there could be a huge timing difference. And we showed that we could apply this timing side channel to extract the symmetric keys. Yeah. So it's possible. Okay. So thanks a lot.